All right, let's look at example 3 here on a travel baseball team. Again, we're focusing on setting up equations, real life kind of problems, and then solving them. Alan's very excited about joining his travel baseball team for the fall season. He wants to determine how much money he should save to pay for expenses for this new team. They're required to pay for uniforms, travel expenses, and meals. Okay, so he's buying 4 shirts at one time. If he does that, he gets a discount of $10. Okay. So the cost of the 4 shirts would be $44. Write an equation that represents the regular price of one shirt and then solve it as I try to speak here. All right, so he's got to buy a shirt, right? We want to figure out how much does one shirt cost. Okay, so I'm going to call that shirt S, but he's buying 4 of them, so I'm going 4 times S. If he buys these 4, he gets a discount. Okay, and his discount would be $10 off here, right? And his total then is $44. Okay. So he's going to buy 4 shirts. If he does 4 times however much one shirt costs, he gets a discount of $10, and that total is 44. And again, how much did one S cost? How much did one shirt cost? So I'm going to go keep, change, and I'm going to make that a negative 10. Okay, just because it's a good practice to start getting into that as we change our thinking to combining positives and negatives. Hey, guess what? Solve an equation. Same thing we've been doing. There's my wall. Simplify each side. Don't add these together. Not like terms. Nothing to simplify here. Find your unknown. Find your symbol representing your unknown number. That's S. It represents the unknown cost of a shirt. So I'm going to solve for 4S. So I'm going to get rid of whatever's not in the square here. That's a negative 10. So what can I combine with a negative 10 to make it go away? Positive 10. Now if you left that as minus 10, guess what? You'd be adding 10. Same thing. Okay? Whatever I do to one side, I do to the other. I have 4 times S. I double check to make sure they're opposites. And remember, we learned that when you add opposites together, you get 0. 44 plus 10 is 54. All right, now this is 4 times S. So I want to do the inverse, the opposite, and divide by whatever this is, because 4 divided by 4 is 1S. Whatever I do to one side, do to the other. 54 divided by 4 is 13.5. What is the cost then? That's what we figured out here. The cost is going to be $13.50. That's what this means, okay? Solve it and then be able to use your answer in a real life situation. Know what it means. So, what is the cost of one shirt? I'm sorry. What is the cost of one shirt without the discount? That's $13.50. What is the cost of one shirt with the discount? Well, if he bought 4 shirts, he got $10 off, right? So, what is the cost of one shirt with the discount? All right. So without the discount, they'd each cost $13.50. Now remember, he spent a total of $44. So if I go the 4 shirts he's buying, so 4 times whatever the cost of the shirt is, that equals $44 what he spent. So again, we just have this one-step equation. It's multiplying, so we divide, and we get the cost of one shirt is $11. Okay, with the discount. Without the discount, it was $13.50. With the discount, it's $11. So how much more do you pay for shirt? How much more do you pay per shirt if you buy them one at a time? Well, without the discount, he was going to pay $13.50. But with the discount, he's paying $11. So if I subtract that, he is saving $2.50 per shirt. Okay? So, or he's paying more, I guess. He could be paying $2.50 more per shirt. However you want to look at it. Okay? So again, this being able to solve equations, guys, it's not necessarily a math thing. You might have thought through this stuff in your head, and it's about the same thing we're doing, okay? Trying to figure out an unknown number. Let's transfer back now to solving equations. And I want to give you a couple examples that you're going to see in your homework. So it's important that you know how to solve these, okay? And I'm going to come out here and write this out here so I have lots of room. Okay? All right. This one always messes up people because we don't fully understand what this means. Okay, it's a fraction bar, it's a division bar, it's a grouping symbol. So if you think order of operations, right? Parentheses, we always say, that's actually grouping symbols. We can't figure out what this X is until we get this all by itself, the whole thing on top, okay? So don't try to get rid of like the -5 here or anything when you have this 3 on the bottom, okay? So here's my hint. When you have something like this, let's get rid of this 3, okay? These are kind of like the ones I said before we're going to expand on. This whole thing right here is being divided by 3. How do we undo dividing? Multiplying. So what happens when I multiply by 3? Now, guys, I am writing this as 3 over 1 just so you can see that we have a 3 on the top and a 3 on the bottom, okay? Because if you go 3 times 3 like this, that's 9. That's not what we want to do, okay? So I'm multiplying this whole thing here, lost my 3, by 3. Now, again, these 3's cancel out. If you have one on the top, one on the bottom, they cancel out. And I'm left with 1 on the bottom, right? These all work out to 1, so that doesn't mean anything. So now I have -5 plus x equals 15, because 3 times 5 is 15. Now, I'm solving for this x right here. I have to get rid of this -5, right? Solving for this x, for this unknown number right here. How do I get rid of -5? Now, this is one of those cases where I'm like, well, I'm adding 5. That means I have to subtract 5. Well, what's -5 plus a -5? It ain't 0. So that's why I want to change our thinking a little bit. I know I have to get rid of this -5. What can I combine with -5 to make it go away? Well, a +5. And whatever I do to one side of the equal sign, I do to the other. Again, if you guys want to put those walls in, you absolutely can. We double check to make sure that's 0. We get x equals 15 plus 5, which is 20. I've got 1x. I'm done. Don't go any further. Okay? So sometimes equations can look a little different, so I want to give you some hints here. Okay? When you have a number on the bottom like this, if you multiply each side by that number, it goes away. All right, the other one I want you to be aware of is this right here, okay? 12 times the quantity. When you hear me say times the quantity, it means parentheses. X plus 9 equals a -108, okay? Now, use the distributive property. It's probably the easiest. We don't have to. We actually could divide by 12 right away, but let's use the distributive property because that's our comfort level right now. We'll get to the other things later. So 12 times x is 12. Do not write a 9 here. Some of us are still doing that, you guys. Remember, it's 12 times everything in parentheses here. If I didn't want it times everything, I wouldn't write the parentheses. Grab a calculator, go 12 times 9, and you get 108. Okay? So now, when you get to this point, it should be pretty, look familiar. We're solving for x, so I'm going to solve for the x term. So this is plus 108. Or it's a positive 108. What do I combine with it to make it go away? A negative 108. Whatever I do to one side, I do to the other. I'm left with 12 times x. This cancels. Equals, grab a calculator. This is not 0. -108 minus 108 or plus a -108 gives us a -216. Now this is multiplying, so we undo that with dividing. Whatever we do to one side, do to the other. And we have x equals -216 divided by 12 is a -18. And just to remind you guys, sorry, that's sloppy there, we can know if we're right by plugging it in. I could write 12 times -18 plus 9. Does that equal a -108? And then follow order of operations. -18 plus 9, because we do what's in parentheses first, would be -9. Does that equal -108? And when I take my calculator and I go 12 times -9, guess what? I get -108. So before you even turn it in, you can know if you did it right or not. Okay? Again, follow your steps for solving equations, okay? We're going to do the same thing. Even though the numbers might change, if they're positive, negative might change, we're going to do the same thing every single time we solve equations.